Welcome, and in this lesson, we're going to talk about umask. Now, umask is a command which stands for user mask. Now, whenever we are using a text editor or using a command like make dir to create a directory, what happens is the process that's actually performing those tasks are setting permissions on our end result. So when we create a text file, our text editor process is going to create specific permissions on that file. Same thing when we use the make dir command. Now, what I want to ask to you is, where do you think those default permissions are actually set? So we know that we can set permissions on files and directories after they've been created, but what about the default permissions for when they are initially created? And we can see our default umask permissions, or our current shell umask, by typing umask. Now, what we need to understand is there's multiple ways of setting umask. And before we learn about it, what I want to show you or tell you, when we're executing our command umask and setting it's setting it for our current logged in shell session. It's not persistent, which means if we were to log out of our system and log back into the system again, it would be set back to whichever our persistent umask settings are. And we will learn how to set persistence on that. And I want to encourage you to make sure you think about, should I set persistence on umask when you're working on your exam objectives? Now, currently, umask set by default is 0022. Now, there are two set of umask permissions inside of our machine. When we set umask, we're setting umask for privileged users, and we're setting umask for non-privileged users. And of course, privileged users considered being the root user or users that belong to the wheel group. So you'll notice that as the root user, my umask is set to 0022. What does this mean? And what is umask doing? So we know that umask is allowing our default permissions to be set. But when we work with change mod, we're actually saying what we want the permissions to be. Well, what umask is doing is it's hiding, or quote unquote masking, those permissions that we don't want the default to have. Right, so each file, when we create a file, technically speaking, our umask is going to start at 666, and for directories, it's going to start at 777. Now, if we don't put in a leading zero there is assumed. Now, when we say mask 6, what is our 6 octal notation? We know 4 is read if we were to set it using the change mod command, and 2 is write. So 6 would mean for the owner of the file, the default permissions would be nothing, because we're saying remove or hide those permissions. So I'm going to navigate into my temp directory, and I'm going to demonstrate this. My current umask is set to 0022. We know that this last notation there is for all other or world permissions. This one is our first 2 there is for our group, and then our second 0 there is for our user. So we're not masking any permissions for the user owner. So that user is actually going to have read and write privileges. Because remember, if we're going to create a file, it's going to be based off of the program or process that creates the file, what permissions is required. Well, a text editor doesn't need to apply execute permissions to a file. So by default, it's not going to give those execute permissions. And in fact, umask won't ever give execute permissions on a file. But on a directory, in order to change into a directory, again, I'm not saying list the contents, I'm saying change into a directory, execute permissions are required. That's why for directories, we assume the starting point of 777. So since it's 022, I'm going to go ahead and tell you what this should be. So it's going to be for the user that owns the file, it's going to be read-write privileges. For the group that owns the file, we're masking write privileges. Remember, write privileges are equal to 2 in our octal notation. So we're masking those. So for the group owner, they will have read privileges, and for all other, they will have read privileges. So we'll do a touch, file 1, and then an ls-l, and we will see that our default permissions, because I'm the root user, and because for the root user, our umask is set to 0022, we're not masking any of the owner privileges. So because it's a file and our process set the permissions, it's going to be read-write. So we're not masking, we're not hiding any of that. Remember, files start at 666. We don't use execute permissions when defaults are set with files, but we do when they're set with directories. And then we're masking the write privileges, which is 2-octal notation, which means 4 is being left to be set, and 4 is read, and that's for the group owner. And then all other is also read. So let's go ahead and look at this some more. I'm going to change the umask for my current logged in shell. Again, when I just type the umask command, it's not setting persistence. So we're going to say, all right, well, I'm going to allow read and write for the user owner. So we're not going to have any zeros there. And if we skip that fourth or the very first preceding zero, it will be assumed. So we can actually just do 0 to represent our group. Now, that 0 is our special permission bits, which we can use to set, but generally we won't do that with umask. So for our user that owns the file, we're going to set 0 because we don't want to hide or mask any of those privileges. We want read and write to be available. For the group that owns the file, we want the same thing. But for everybody else, let's say we don't want to give them any permissions by default. And so we're going to mask or hide all of those privileges. So we could say 006. If we touch file 2, do an ls-l, we will see that everyone else does not have privileges. But since files start at 666 and really directories start at 777, what happens right now when we create a directory? So we'll do a make dir, dir1. And again, we'll do our ls-l for our long listing. And in our directory, we see that the owner has read, write, execute. The group owner has read, write, execute, and everyone else has execute. Well, what I want you to remember is just because there's execute privileges doesn't mean there are permissions to list the contents in the directory. So everyone else, or people that don't belong to the group that owns the file, or are not the user that owns the file, they can change into the directory. They can do a cd dir1, but they cannot list the contents of the directory. And so that's why we start, or say we start with 777 on directories, because generally speaking, we're going to always want to leave execute permissions on a directory to navigate into it. We might want to prevent the user from listing the contents of the directory, but generally it's best practice to go ahead and leave execute privileges. So what would happen if we wanted to say, I want, whenever my user by default creates a file, and again, we could be writing a script, and a script could be creating files, and when the script creates a file, we might want it to, by default, set specific umask privileges. So inside of our script, we could issue the umask command, so everything that it does in that current shell session or interactive shell that's running the script, it'll be for that umask. Let's say I want our defaults to be read, and then no privileges for the group or other. So to do that, I'm clearly going to mask the write privileges for the owner of the file. So we're going to say 2. Think about it like this. We're removing the 2-octal bit from the permissions. 2 is write, and all that is left is read. So we're going to remove the 2. And then we're actually removing everything else. So if we were using change mod to set this, we would just say 00. But since we're masking, we're going to go ahead and mask 66. Remember, 4 is read, 2 is write, 4 plus 2 equals 6. So we set our umask to 266. We'll do a touch file 3 and ls-l, and you'll see that the owner that owns the file, which is the root user, will only have read privileges. Everyone else, the permissions were masked or hidden, so there are no read or write permissions on file 3 for the group owner or everyone else. So again, if we were to do a make dir, dir2, and do an ls-l, we would see that the user that owns the file would have read and execute permissions. Everybody else would have execute permissions. And the execute permissions just allow us to change into the directory. Now, because directories need execute permissions to work, right? Our make dir program needs the execute. That's why it starts at 777. Our text editor is never going to need to set execute permissions on a file. It doesn't need to execute that. The only time you need to execute a file is if it's really a script. So let's say I want to hide all permissions. I want just default absolutely nothing, even if it's a directory. I don't want execute. I could say umask 777 We'll do a touch file 5 and a make dir 5. We'll do an ls-l. You'll see that there are absolutely no privileges on our directory. The D again just represents directory, and file 5 there are absolutely no privileges. Umask is used to set the default permissions on files and directories. When we issue the umask command inside of our terminal, it's only for that individual login session. So for example, if I type umask, this is my current set permissions. If I exit as the root user and open it back up again, and we type umask, it's going to go back to what it's set at login. That's called persistence. So how do we change our persistent umask settings, or the default it should be for users when they first log into a session? So how do we do that? We're going to go into the etc directory. I'm going to clear my screen here, and then we can do a vim on our bash rc and our profile. Now, one thing that we need to remember again is our bash rc configuration files for our interactive shells. That means this is the configuration that's going to occur whenever an interactive shell starts. An interactive shell is really anything that allows us to type or pass parameters at the command line. An login shell is going to have the configurations of the profile. Now, technically speaking, I didn't use the su dash, so I'm not actually inside of a login shell right now. So our bash rc, we can set settings, and then in our profile, we can set settings for our umask. And what we're going to find, we're going to start with vim. In our etc directory, we're going to do bash rc. And what we're going to find, and if yours doesn't open up, you can do the / and type umask, and it's going to search and browse down to it. Mine was already open, so that's okay. And what we're going to find here is they're going to both basically match configurations. So if you see here, we have an if statement. This is a script, and it has a condition that says if this condition is met, then set the umask to 002. So all this script is doing is it's executing the simple umask command every time an interactive shell is opened. And anytime we log into our terminal, that's an interactive shell. A login shell, usually when we log in for the first time, is a login shell. If we change into a user, like changing into the root user, we need to specify a login shell. So what is this if statement? What technically is happening here is it's saying if it's not a privileged user, which means if the user's not root and the user does not have sudo privileges, then set the umask to 002. What does this do? This says whenever somebody that the user's umask matches this creates a file, touches a file, anything with a file, they're going to have read-write privileges for the user owner, read-write privileges for the group owner, read privileges for all other. Why? Because for all other, again, when we have 2 here, we're basically removing the write privileges. So 6 minus 2 would be 4, which leaves 4 for the permissions that are set. We're masking. We're saying what we're hiding. We are hiding our write privileges for all other users. Because again, we have the other permissions, which are also considered world permissions. But here we're saying if it's a privileged user, then the owner that owns the file, when it creates it, when it's a privileged user creates it, will have read-write privileges. The group that creates the file will only have read privileges. And all others will only have read privileges. So what is this logic saying? How is it really doing this? Well, what this is doing is it's saying if the user's current user ID, and UID is actually an environment variable set inside of the shell. And you can see that by typing env at the command line. Environment variables are specific configurations that are available or set whenever we log in. And all this is doing is setting that environment variable. And it's saying if that environment variable, which is our user's ID, is greater than 199. So system users that are between 1 and 200 are system users for Red Hat processes. For other system processes like HTTPD, they're going to have a user ID of 201 to 999. So here's what this logic is saying. If the user's ID is greater than 199, and, this means and, the group name, this ID shows user ID, group ID, supplementary group IDs, and group names. These flags specify look for the group and return the name. If that matches the user's name, this is returning the user, matching with name instead of ID. So if the group name equals the username, then umask equals 002. So if it's greater than 199, the root user has a user ID of 0. So that user is clearly a privileged user. So immediately he's going to be taken and have the umask 022, which we've already looked at. But if it's greater than 199, so we know it's not the root user, and this condition is met, what is this condition saying? Well, when a user is a privileged user, their primary group or effective group is going to be the wheel group. We can't add a user to a supplementary group wheel group and pseudo privileges work. So if pseudo privileges are working, that means their effective group, their current logged in group, their primary group is the wheel group. Now, whenever we create a user for the first time, it creates the user's username, and for the primary group of that user, also matches the user's username. So for regular users on the system, we're probably going to keep their primary group of their regular username, but we're going to add them to supplementary groups. But for a privileged user, we're going to change their primary group, their effective group, to the wheel group. So in other words, this condition will not be met. If you're a privileged user, your primary group is the wheel, so your group would be wheel, and your username would not be wheel. So this condition is not met. So if these conditions are not met, then the umask is set to 022. So this is for privileged users. If the conditions are met, then you're a regular user, and your umask is set to 002. Now, if we were to go take a look at our profile and we do a search for umask, the same exact conditions are set. So we're basically saying regardless of it's an interactive shell or login shell, these are the conditions we want to have. Now, you could say if you were tasked to change the umask, the default permissions for new files and directories for regular users on the system, how would you do that? Well, we would go into both of these files, and let's just say we're tasked with setting the umask so that the owner, the group, and all other only have read privileges. We would come in here and we would change this to 2, and it would be 222. So it would only be left with 4 read privileges. And then we would exit. And then, of course, do our bash RC, find our umask entry. If it's not there for you, you can just do a search, / type in umask. And then we would change this to the exact same, 222. We'll save and exit. So currently our umask is what I left it at when we just logged back in. Now if we log out and we log back into our user on the system, we'll enter in our password, and we type umask, our umask is going to be set to 0222. And we type umask, our umask is going to be set to what we just set it to. However, if I go ahead and log in as the root user and I type umask here, it's going to be 0022. Because remember, privileged users and regular users on the system have 2 different configurations. We set the regular users, this is for privileged users, and we have to edit both the etc bash rc and the etc profile in order for this persistent change to stay. Now, a few more things, if we were to navigate back into our temp directory, if we wanted to remove all privileges, and again, if I type the umask command here, it does it for this current shell. So that means I can also use this inside of scripts. I could say umask 0, and that's going to say don't mask anything at all. So if we were to touch test1, do an ls-l, and look for our test1 file, it's going to show all read-write privileges. If we did a make dir test1, ls-l, you'll see that our dir test1 has all read, write, execute privileges. Because again, for one last time, files don't need execute privileges. So if you look at it when you're asked to set it for a file, you would start at 666. If your goal was to set it so that the owner that owns the file has read and write privileges, but the group and other permissions are only read privileges, you're going to say and look at it from this. Do I need to subtract anything in order to get read and write? No, because 6 actually equals read and write, 4 plus 2. So our command would be umask 0. Then for our second, our group ownership, we only want it to be read, So we need to subtract 2. So we're going to mask number 2. And then same thing for the last one. Our umask would be 0, 2, 2. So that concludes it for this lesson. At the end of this section, there's a great exercise that walks you through doing this. Sometimes umask is a little bit tough to understand, and that's why I'm using words like mask and hide, because really we're hiding those permissions, and that's really what mask means. And so that concludes it for this lesson. So go ahead and complete this lesson.